Hey guys, welcome back to General Chemistry 1, Chapter 1. We are going to move into talking about units of measurement for this chapter. So, units of measurement, there's SI or Standard International Units of Measurement. There's measurements that we here in America use kind of at our own will. And then there's measurements that maybe aren't standard international, but are standard in the science world. Okay. So you'll see all kinds of different types of measurements this semester. For the SI units, length is usually in the unit of meter. So with that being a metric unit, you'll often see centimeters with that prefix centi, making it a little bit smaller. But length is in meters or centimeters, you'll see quite often. Mass, so the SI unit for mass is a kilogram. When working in a general chemistry laboratory, measuring things out in kilograms maybe isn't the most efficient way to do things. So very, very often when we talk about mass in chemistry, we will talk about the gram. Time will be in seconds. So this is something that SI and America actually have in common, so nothing new to learn there. Temperature. So the SI unit for temperature is the Kelvin. This is the scale that does not have negative, so 0 is the bottom, and that's why Kelvin is the SI unit. We will use Celsius quite often, and you will also see Kelvin towards the end of the semester. But Celsius and Kelvin are where we're going to live there. Electric current, we don't really talk about electric current much in general chemistry, but if we did, we would talk about the ampere or amp. And then a unit that you will get to know and love this semester is the mole. So when we talk about an amount of substance, we typically use moles as chemists. So introduction to some of the units that you're going to see. We do use the metric system for sciences. So here are some of the metric prefixes. So prefixes make a base number bigger or smaller based on the prefix. So here, first prefixes you see will make a number smaller. So multiply by 10 to a negative exponent. I do not make you responsible for all of these. So I don't ask a lot about femtoseconds or picoseconds or picometers. But there are three that I think you should commit to memory. And that is the milli, and micro. Centi, milli, and micro. So centi, I've already alluded to that, centimeters. Milli, because when we get to the volume chapter, we talk a lot about milliliters instead of a full liter. So going between liter and milliliter, you'll be able to do that in your sleep. And then micro, I think, is important because it's used very often in medications. So lots of medications are not dosed in milligrams. They're actually dosed in micrograms, things like vitamin D, any of your thyroid medications, Synthroid, levothyroxine, stuff like that. So I think micro is also an important one to know. Here's the set of prefixes that make a number bigger. So we multiply by a positive exponent. Again, we don't talk about a lot of giga or teras in chemistry, but one I think you should commit to memory is kilo. That is the SI unit for mass. So being able to go between kilograms and grams will be helpful. Also, when we get to thermodynamics at the end, going between kilojoules and joules will be something you'll need to be able to do. So commit it to memory now, and when we introduce new stuff later, you'll have it. Other important units for you to know are temperature units. So we in America like to live in Fahrenheit, but science world uses Celsius or Kelvin. So here are some temperature conversions for you to have. You will be asked to do some temperature conversions throughout the semester, so it's important that you do understand where they came from. So going from Celsius to Fahrenheit, this TF here stands for temperature in Fahrenheit. So that's our destination. And this TC here stands for temperature in Celsius. So If I take a measurement in Celsius, I put that number in here, and I chug through it to get to Fahrenheit. Going back the other way, so Fahrenheit to Celsius. So I'm here in America, and I'm like, oh, room temperature, that's 70 degrees Fahrenheit. What is that in Celsius? So you'd plug in your 70 here, subtract 32, divide by 1.8, and that would give you your temperature in Celsius. And then lastly, going from Celsius to Kelvin or Kelvin to Celsius, it's a simple addition subtraction. So you would take your temperature in Celsius and add 273 to get to your temperature in Kelvin. There is no direct path between Fahrenheit and Kelvin. So if you are saying, okay, room temperature is 70 degrees Fahrenheit, what is that in Kelvin? You would have to do a two-stepper. You'd have to go Celsius, then to Kelvin. So that's just your quick introduction to temperature conversions and units of measurement that you will see. I hope you found that helpful.